In this experiment, we are going to trace the path of the rays of light through a triangular glass prism. The material required is a glass prism, a drawing board, protractor, a measuring scale, a sheet of white art paper, drawing pens, or sellotape. On performing the experiment, you will learn how to trace the path of light through a glass prism. So the ray of light that comes in from the left is the incident ray. At this point, we draw a perpendicular to the face AB of the mirror. This is known as the normal. So the angle which the incident ray makes with the normal is known as the angle of incidence. So in this case, this is the angle of incidence. And when it travels from air to glass, that is, it is traveling from a rarer medium to a denser medium, the light ray will bend towards the normal. So the angle of refraction would be smaller than the angle of incidence. Similarly, when this refracted ray travels from point Q to point R, and then finally it comes out of the prism in the form of ray RS, it again forms an angle with the normal, which is known as the angle of emergence. So the ray that finally comes out from the other end of the prism is known as the emergent ray. If we extend the incident ray in the reverse direction and we also extend the emergent ray in the reverse direction, we get an angle here. This is known as the angle of deviation. So let us see how this has to be done experimentally. Let us now see how refraction occurs through a triangular prism. So this is a triangular prism. As you can see, this is the triangular face of the prism and this is the rectangular face of the prism. So we have to place the prism on the sheet in such a way that the triangular base is at the bottom and at the top. So after placing the prism on the sheet, we will mark the boundaries around it with the help of a pencil. I have already done that. So you can see the boundaries have been marked here. And then along this face of the prism, we will draw a dotted line in such a way that this dotted line is perpendicular to this line. And after that, we will just draw one line at an angle to this normal. Now, this angle depends on your choice. You can make it 30 degrees, 45 degrees, 60 degrees, or whatever angle you want to take. You can measure it with the help of a protractor and then make it, or you can also make it just by your choice. So after doing this, we will place the prism back at its position and we'll fix two drawing pins here on this line. So I have fixed the first drawing pin here and the second drawing pin at a distance of approximately 2 centimeters or one and like more than 1 centimeter, 2 centimeters should be the gap between the two drawing pins. So the prism is now in its position. So this is the setup that we required. These two drawing pins are indicating the incident ray of light. Now we will trace the path of light which is going along this path from this face of the prism and we will draw the path of the emergent ray on this side. So let us have a view from this side what it looks like. You will see that these two pins will appear to be in a straight line at this end. Now we will add two more pins over here in such a way that all the four pins will look like as if they are in a straight line. So I have fixed two more pins over here and it's looking like as if 1, 2, 3, 4. The yellow pins and the green pins, they are in a straight line. But let us check, are they actually in a straight line? Let us have a look from the top. So you can see that the lines which we were thinking that as if they were looking like as if they are in a straight line were not actually straight. So let us now complete this figure. I am going to remove the pins and I am just marking the points where the pins had been fixed on both the sides. And I'm also removing the prism now. With the help of a ruler, I'll be joining these two spots So this is the emergent ray coming out. This was the incident ray. You can join the two with the help of dotted line showing the actual path, or you can even use a bold line for this. Then just like the way we made a normal at this point, we'll be making a normal at this point also. So normal is perpendicular to the surface. So make sure it's a perfect perpendicular. So for drawing a normal, we'll be using dotted lines. So this marks the normal at this side of the prism or this edge of the prism. So this angle here is the angle of incidence. This angle here is the angle of emergence. And this angle here marks the angle of refraction. If we extend the incident ray further, I'm using dotted lines to do so, and we also extend the emergent ray in the reverse direction. Again, I'm using dotted lines for doing so. We get an angle here. This angle is known as the angle of deviation, which is marked by the letter small d. Also, this angle marks the angle of the prism, that is A. So we can call the prism A, B and C. The triangle that we see on the prism can be called as A, B and C. So this is how refraction occurs through a triangular prism.